All right, let's finish this example. I know I sent you on your way to do this on your own, but as I started doing my table, I realized that this point 0.5 might not be something you've graphed very often. So I wanted to make sure I talked through the graphing part of it. Although I really feel that your input-output table, that you did just fine on that. So let's look at the ordered pairs. We're looking at, in this case, the order. So we've got 4 points once again. Notice that this time we're not going to see that because the change in x values is not consistent. It changes by 2, then it changes by 1, then it changes by 2. We weren't as easy to see that pattern like we saw in the previous problem. But let's graph those points. 0, 0, 2, 3. I think those are both easy. It's this one right here, 3, 4.5. So we're at an input of 3, but the output is 4.5. It doesn't happen right at a cross section or right where two lines cross. It's in between. It's in the space. That happens when we have fractional things we need to graph. 5 and 7.5. Again, it's a fractional piece that we need to graph. In this problem, we only have a limited domain, so we do not need to go any further. Just dots. Do not connect the dots. Now we have to write the rule. So we're going in the other direction. They've given us a graph, and now we have to come up with a rule. It really allows us to bounce back to section 1.6, where we had those write the rules. So now we're going to make a table for a graph instead of a graph for a table. Remember, input values first, then output values. The first input is 2, and its output, or its height, is 0. The next input is 4. It has an output of 1. The next input is 6, and its output is 2. We go to 8. It has an output of 3. We go to 10, and it has an output of 4. Be really cautious that when you're reading these charts, that you make sure you read their scales. If it's not labeled, it counts by ones. If it is labeled, then obviously it may count by something different. Now we need to work on finding a relationship between the input and output values. To find that relationship, I like to go back to that old slope-intercept form that you've learned a long time ago. I always like to put that the output is equal to something times the input plus or minus something. Let's go through and work through this. This multiplier, or this rate, what is the rate that x changes at, is easiest to find by doing that change in y and change in x. Look at your y values. How do they increase? This one has a nice consistent add 1, add 1, add 1, add 1. So the change in y is equal to adding 1. Now let's do change in x. What happens when what do we get here? Between 2 and 4, we had to add 2. Add 2. Add 2. Add 2. So my change in x is to add 2. This multiplier in front of x in my relationship or my rule is always going to be, oops, wrong color, undo. We need to do the change in y over the change in x. That's going to give us that multiplier, that rate. So we'll have whatever the change in y is over the change in x times x, and then we might need to add or subtract something. So let's check it out. This problem has a change in y. Change in y was 1, so we're going to say y equals, or the output equals, the change in y, adding 1, over the change in x, adding 2. We're going to multiply that times our input. And then do we need to add or subtract anything becomes our question. So let's find out. Positive 1 over positive 2. So that's really a 1/2 times x. We know that this is the multiplier. Change in y over change in x is always the multiplier. The rate. If I do half of an input, so half of 2, well, that's 1. It didn't get us to our output. What could I add or subtract to get to 0? Because I want to do 2 times a half, and then I want my output to be 0. Hopefully you saw right away that means I need to subtract 1. Does it work for all of the points? If you do half of 6 and then subtract 1, do you get 2? Half of 8 and then subtract 1, do you get 3? Half of 10, then subtract 1, yep, we get 4. So that was our step 3 and step 2. They work well together. We need to find that relationship, and the purpose of finding that relationship is to write a rule that describes the relationship. A rule for this particular function is y equals 1/2 x minus 1. The domain of the function, as long as they're giving me domains, as long as my line isn't drawn in, then I can just list them as numbers. 2, 4, 6, 8, and 10 are my domain values. And my range is 0, 1, 2, 3, 4. 1, 2, 3, 4. Oh, one for you to try all the way on your own. Graph the function with the domain. All on your own. Yep. Give it a try. Alright, so hopefully you paused it and you really gave that problem a try. I just want to point out that if you use a horizontal table or a vertical table, it doesn't matter to me which one you prefer in your homework. I think that the vertical table is the one we're most familiar with, and that's probably the one that you will see not only on your test situation, but also most likely on my work more often than not. I want to make sure we go through graphing this one again, because if you notice the way that this table is, or this graph paper is labeled, it counts by 2's on the x-axis, on the independent axis. So I want to make sure that I talk through graphing one more time. So the first ordered pair is 0, 1, and that's where that point came from. The next point is the point 3, 2. So an input of 3 and an output of 2. So again, it's going to have us ending up in that space and not at a pretty joint like we're used to. 6, 3. See, that's a nice pretty point. 9, 4. So in between and up to 4. 12, 5. A limited domain means we cannot connect these dots. And I believe that makes us, we have one more checkpoint. Write a rule for the function represented by the graph. Identify the domain and range of the function. This is another of those ones. I want you to try it on your own. So pause it, give it a try. Remember your steps. Draw your table, find the relationship, write a rule. When you do that, find the relationship. If you can just see it and you can just write your rule, write your rule. But a lot of people can't see it right away, which is why I showed you that change in y over change in x. It will work every time for these problems. But if you just know it, you don't have to do that change in y, change in x stuff. Give it a try. Okay, I'm flipping in a little early on this one. I want to make sure that you got your table set up correctly and you saw that the table doesn't count by ones, it counts by twos. And we have spots, and we have points that are in the spaces. So I just want to make sure you got your table set up. Alright, if you finish the problem and your table is good, then give me a second. If your table wasn't good, fix your table and rewrite your rule. I'm going to pause it, finish it, and then I'll unpause it and finish recording. Alright, so here's what I came up with. I discovered that my change in y was adding 1. My change in x was adding 2. So when I filled in, oh, I need to do that one. When I filled in my formula, y equals change in y over change in x times the input, then add or subtract something, I ended up with y equals 1/2 x, and I needed to add 5 in order to make that work. That should be the end of our 1-7 notes and make us done with chapter 1. Yep, it is. So the next piece we have is studying for that test. Good luck.